Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host, Nathan Oakley, and if you are new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to keep up to date with the community Flat Earth Debate, then go to nathanoakley.com and join the community forum there. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they're live. And there's also a Patreon, PayPal and crypto link in the info box below the video. Most importantly though, if you would like to join the discussion, then simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, we are joined by Zinda, Sleeping Warrior, who's that with their icon, Paul, Kosho, Flat and Earth, Eben, Chocolate Saying, Bob the Science Guy, and Arwin. Good to have you all.
Good afternoon.
Glad to be here, Nathan.
Good morning.
Hey, Bob, if I could show you something that could show you that refraction can throw off any measurement, would you accept that?
Of course.
Okay. If you look at my screen, there's a video. I'm not going to show the whole thing because it's about 35 minutes long. But this is an experiment that was done in the Philippines, and they took a flat surface with a local sun or a small sun that was local or whatever, and walked through showing measurements, and they showed how they could determine the flat Earth from a local sun. But then they added a lens over that and actually worked out the formula and the calculations to show that they could work out a spherical Earth from it.
Okay.
Flat surface. So I would highly recommend watching this video, because this would account for even your sextants, because if you're trying to measure the stars or the sun, if there's any refraction at all, it would throw your measurements off.
Okay, great.
So before this is back to what we've been saying about presupposing. You're presupposing something, but here's a piece of evidence to show that everything you're saying could be completely wrong.
Okay. Well, let me just add this then, because I actually did look into that. I looked into the possibility that maybe the firmament was acting as a lens and disrupting the light from Polaris to try and divert it down to make the sextant work right. Now, the problem that you run into that is the refraction index of that has to be significantly less than 1 in some places. Okay, that's not possible. Now, here's the other problem. Do you believe in trigonometry? So, for example, let's look at some triangles, okay? If you have a flagpole and it casts a shadow, and that angle of that shadow is 45 degrees. Do you agree with the concept that from that point to the base of the flagpole equals the height of the flagpole?
I would agree that if you watch that video, they go through everything you're talking about. Go through everything you're talking about. So I don't have a problem. You've not watched
let me
the video.
finish this real quick. So we know that at the North Pole, which is acknowledged by both flat and globe Earth, right? At the North Pole, Polaris is, shall we say, directly overhead, 90 degrees up. So it forms a right triangle with the surface of the Earth. Now, if we go to 45 degrees north latitude, there is a 45-degree angle to Polaris. So therefore, by trigonometry, and this presupposes nothing, distance 45 degrees north latitude to the North Pole must be the distance from the North Pole to Polaris. Would you agree with that?
No, that's only if you presuppose that it's actually a tangible object in a specific location, which is exactly what triangulation is for. You don't have any proof that it's physical or in any specific location at all. Yeah, just have angular relations.
Okay, so that's your argument when I'm pointing out the fact that it's at a 45-degree angle, you say it's just not real.
Yeah,
so
that's my argument. You got an angular relation. You don't have confirmation of a physical, literal location. That's exactly my argument.
Okay, all right.
That's
how would you falsify that argument?
Well, hang on.
How would you falsify it? You'd actually have to prove that it is in a physical location to begin with.
I can do that.
In order to engage in actual triangulation. Because otherwise you're going to just have to presuppose it is.
But you have to tell me how that can be falsified though. So can you falsify the fact that I see it at 60 degrees north, I see it at 60 degrees, and at 45 degrees north, you see it at 45 degrees?
I don't have to falsify it. I confirm it. Yeah, you do see it at these angular relations in relation to the position of the Earth. Yeah, you do.
Okay, so
you just don't have any proof it's actually literally in a physical location.
Okay, so your answer to this is that it's not real. Okay.
No, I'm not saying it's not real. I'm just saying you have no proof that it is physical and in a physical, literal location. You only have the angular relation because that is what you can observe. And it's the only thing that you can observe about it.
Angular resolution that it was at 400 light years, for example.
Oh, where's your proof for that? Where's your proof for that? Where's the proof for the distance?
It's parallax.
Bob, can we stop talking about things 400 million light years away and talk about the actual curvature of the damn Earth, please? Can we get back to reality
at this point to maybe
so
do a bit of
got 3 different ways that
housekeeping?
we can
Oh, my
determine
bad.
the
I was
curvature of
talking.
the
That
Earth.
was obviously Bob. Yeah, that'll be my chance to do a bit of housekeeping. So we'll rattle our way through the housekeeping questions. Is there any signs of Earth curvature?
Yes.
Nope.
Excellent.
Continue.
Yeah, that would be your opportunity to give us the demonstration of Earth curvature, as opposed
No,
to just...
you have housekeeping at the
I
beginning.
hadn't actually finished my sentence. I used the word as opposed, meaning that I was continuing a sentence, Bob. Please, can you not interrupt me every single time I talk? So that would be your opportunity to actually present something beyond your fundamentalist belief. So you can choose to take that opportunity during the silence.
I choose not to.
Oh, so it's just your fundamentalist religious belief. Don't continue to talk then. If you're not going to take the opportunity to actually present evidence of Earth curvature, then shut up. No, we don't just accept you saying yes. Bob, we don't just accept an answer of yes as proof of Earth curve. Okay?
Well, are you going to continue your housekeeping?
I run this show, Bob. Are you used to being in a position where you run the show? Because here you don't.
I'm asking if
you don't need to give me a permission. You don't need to ask. You don't need to do anything except answer my questions when I address you. That's all you need to do. Don't worry about my questions. I'll worry about those while you talk all over me. So, is there any signs of axial rotation of the Earth-based variety?
Yes.
Show it.
You're just going to claim it and just say, yeah.
So just your fundy belief again.
Housekeeping questions. That's all I'm doing.
Just giving us your fundamentalist belief. Just giving us your fundy belief.
That later.
No, that's why we do housekeeping. It's like if you say yes, we expect you to actually present something.
I'm taking you off script, Nathan. I'm not playing your game. I'm just answering your question.
By not playing my game, you mean not answering my questions. That's what you actually mean.
I did answer your question. I said yes.
Yeah, but you didn't present any evidence. Oh, Arwin, I'm in the middle of a conversation with the guy. Why are you rumpusing me? Yeah, yes is not a sufficient answer, Bob. You actually need to provide evidence.
I will.
Okay, off you go.
Do it.
Any evidence of axial rotation?
Yes.
That's not how it works. You actually,
so present it then. Yes, implying you have some, while Arwin talks all over me again, and then Bob continues to talk over me. So you actually have to present the evidence. It's not a secret that you're here to hold.
I'll go right ahead then. All right. So you want axial rotation?
Well, you said yes to Earth curve, so let's start there.
Okay. All right. We'll start yes with Earth curve. Let's see. First of all, we have horizontal drop, which is easily measurable.
We went through this on the last show. In order for you to say that the curve of the Earth is the horizon, you have to presuppose the Earth's a sphere. We covered this on the last show.
I have to measure the horizon. I have to measure the horizontal drop of the horizon.
Yeah, and you're presupposing the horizon is the leading edge of a sphere Earth, aren't you?
I'm not presupposing anything. I'm measuring the drop of the horizon.
Let's just test that. If he's presupposing anything, what's the horizon?
The horizon is the limit of the sky and the land.
So it's not the leading edge of a sphere then? It's not. So it's not a point you can measure then? It's an arbitrary point in the distance that will change, so you can't measure it.
Yeah, but you can see it, and you can compare it to level.
No, it's not a physical thing. It's an arbitrary point where the sky meets the land, contrary to what you said on the last show. So if it's not a physical location, I'm still talking. If it's not a physical location, what precisely, pray tell, are you measuring?
Can you see the difference between land and ocean and sky? There's a line there.
You're ignoring my question. What are you measuring? If it's an arbitrary point where the sky appears to meet the land, what precisely are you measuring?
You're measuring the distance between level at your location and that point.
Sorry, level at my location. So are you presupposing that it's curving away?
No, I'm not. I'm simply measuring the distance or the difference between level at my point and where the horizon appears.
But the horizon is an arbitrary point where the sky meets the land, an apparent position. So explain to me exactly how you're going to measure from your actual position to an apparent position. It's not a physical location to measure.
The demarcation between sea and earth and sky is easy to see. You can easily measure the distance, the angle from your level to that apparent position.
Yeah, but it's an apparent, it's not a physical location. You can't measure to an apparent location. It's not a physical place.
What do you consider it? What do you consider it, Nathan?
Excuse me, this is your example.
And I gave it to you.
It's garbage. It doesn't prove curvature. You suggesting that you can measure from an actual location to an apparent location is not proof of anything.
Okay, what do you consider it, Nathan?
Excuse me, this is your example. Don't ask me what I'd consider. Present something like you have been and I will rip it to shreds.
No, I'll knock yourself out, Nathan. I don't think I'm real worried. But I think that it's very easy to see where the horizon is from any...
It's not a physical thing. There isn't anything to see. It's an arbitrary point. It's an apparent position. So when you say it's easy to see this thing, what? The apparent position that you're going to measure to? No, bonehead. You're not going to be measuring to apparent places.
Okay, Nathan, all right, that's your first warning, Nathan. You called me...
Sorry, you giving me warnings? No, you don't give me warnings, asshole. That's not what happens here. You don't give me warnings. You don't warn me about anything.
I just did. So, what you do is you measure the distance to the...
Bob, you mad corny, bro.
All right, you measure the distance from your horizon.
The horizon is an arbitrary point where the sky meets the land. You cannot measure to it. It changes as you move. So it's not somewhere you can physically go to. It's an apparent position. You keep circle jerking us, Bob.
All right, I know exactly what a horizon is, Nathan.
Yeah, it's the arbitrary position where the sky meets the land. It's an apparent place. It's not a physical location. And you claiming that you know what it is when you declared on the last show it was the leading edge of a sphere, now you're trying to use an apparent position to measure to get around the fact that when you say it's the leading edge of a sphere, I point out that you're begging the question.
Yeah, you see, I'm trying to avoid your little logical fallacy.
No, Bob, so you see, we all noticed very easily how you changed your definition of horizon depending on the question that Nathan asked you.
I did it to avoid his logical fallacy question. So, the difference between your level and the horizon can...
The level of the horizon, there is no level to the horizon. It is not a position you can measure to. It's an apparent position that will change as you move your location. So you're not going to be measuring to it. Why are you continually circle jerking on the exact Same point, you stuck parrot. Has somebody stuck 25 cents in you?
Okay, so you're telling me that sextants don't measure to the horizon. Have you ever used...
Sorry, did I ever say those words? Hands up on the panel. Who heard me say the word sextants don't measure to the horizon? Who heard me say that?
No, you said horizon doesn't exist. And
Yeah, it doesn't. It's an apparent location. It's not a physical place. It's not Spain. You're not going to this place.
Yeah, but you see, Nathan, you're just simply wrong because sextants, I set you up. Sextants do measure to the horizon. And
yeah, you can measure to an arbitrary place that doesn't exist. That doesn't mean it's a physical location, Bob, unfortunately. This fallacious nonsense doesn't mean your arbitrary position where the sky meets the land is ever going to be a physical location you can measure to. As much as you want it to be, you'll never double speak your way around this. And repeating it 16 times won't make the point any stronger.
Nathan, I love watching you scramble.
You know why a sextant requires the horizon to point at? As a fixed position. Yeah, let me explain it to you. It is because it actually measures the angles of the stars and all that in relation to the Earth, and you have to fix it somehow. So they use the horizon since that is the spot where underneath it there will absolutely no longer be any stars. That's the only reason why. It's not because it is a physical location.
Okay, but Nathan says you can't measure the horizon. So how does a sextant work again?
It measures the stars and uses the apparent horizon as an anchor point because that is where the stars will definitely no longer be visible beneath it.
Okay, so it uses...
Not because it's a physical location.
Okay, but it uses the horizon as an anchor point. Yet when I try
for celestial measurements, the intangible celestial bodies above us.
You won't get to actually make a full point without Bob talking over you.
It doesn't measure, you can't measure from level down to the horizon. You can only measure from the horizon to the stars. Is that what you're telling me?
How do I get to the horizon?
Because underneath the horizon there will be no stars visible.
How do we get there?
All right, do we get
Bob. All
right.
How do I get to the horizon? How do I get there?
Oh, let's see. You turn, you walk straight ahead until you find your dreams, Nathan.
Oh, so it's like trying to find dreams. Trying to find this point that you're measuring to is like finding dreams. Well put.
Like finding curvature. It's like finding dreams.
Well put, Bob.
Do you use a sextant?
Well put.
Bob, do you use a sextant?
Have I personally used a sextant?
Yeah,
I did once in high school. Yeah,
we don't care. This doesn't prove globe. Who
So
cares?
practically an angular anchor point, not a physical fixed.
How do you... So you only use them once. Do you adjust the sextant at all when you're using the measurements?
Yeah, you do.
What adjustments do you make?
I don't know. I'd have to pull out.
You don't know what adjustment. Then how do you know you're accurate? The adjustments you make are about perpendicularity error, side error, collimation error, and index error. Now, also, when you when you get the measurements from the sextant, do you also factor in the curvature of Earth into your calculation of the distance between two objects?
I've got no idea.
That's all I want to know.
Yeah. I understand the basic concept of a sextant. I've never actually used one for navigation. I don't use sextants for navigation. I use other means.
That's great. Doesn't prove we're on a sphere. Wonderful. Proves nothing, in fact, because you can't measure to the horizon. It's not on point, as Bob points out. As you go towards it, yeah, Bob's just going to talk over me, of course, while I point out that as you travel towards the horizon, that point, that arbitrary point, that apparent location changes as you go towards it.
Yes.
Yeah, so it's not a physical location that we can measure to or extract data from because it's an apparent position that you claiming you can measure to simply because I point out that you beg the question when you assume it's the leading edge of the sphere. Oh my God, he literally can't let a single guest get to the end of a sentence.
You're not a guest.
Yeah, I was talking about Arwin and that other guy you just spoke over a moment ago. You talk over everybody, Bob. Everybody.
You're gonna have to work that out with your panel. So you know how a sextant works using the horizon, but I can't use the horizon to measure horizontal drop. You'll have to work that out amongst yourselves.
That sounds like projection because it seems to me that one of the panel members has just asked you how to do it. You don't know, and you're telling us we need to work it out for ourselves. No, idiot. You need to go away and figure out how a sextant works, given it's your example that you don't understand. So it seems you're projecting quite a lot of your inability to understand things onto us.
All right, I gave the basic operation of a sextant. Does anybody...
That's fascinating. Wow, how incredibly in-depth from somebody who has never used one. Wow, we all feel so much better educated.
Have you used one, Nathan?
I didn't claim it. I'm not using it as an example, fucktard. You are.
So you don't know. So
yeah, it's not my example. I'm not using it. Burden of proof reversal fallacy. So this is your claim. Why the hell would I need to have when I'm not smegging claiming it? You are.
All right. Well, I'm going to go.
Not all right. You do this every time. I demolish your argument, in this case a burden of proof reversal fallacy, and when I do it, you go, all right. Like it's acceptable for you to use logical fallacy here. It isn't all right, Bob. It's called logical fallacy. In this case, you asking me whether or not I've used the equipment used in your example, that would be a burden of proof reversal fallacy. So no, not all right. Another logical fallacy from Bob the fallacy guy.
Actually, I was just curious if you'd ever used one. It has nothing to do with my argument. Does anybody on the...
Oh, well, we're in the middle of a debate, you stupid dick. Oh, have you ever had cheesecake, by the way, Bob? Have you ever eaten cheesecake? I'm not particularly interested. It doesn't really assert anything to do with my point. I'm just fascinated with whether or not you eat cheesecake.
Yeah, I am. Now, does anybody...
Sorry, we're not here for chit-chat, dickhead. We're here to discuss this actual subject.
The angle from the horizon to a star. Does anybody on the panel disagree with that?
Yeah. Disagree with what?
I just said, does anybody on the panel disagree that the basic operation, as I put it out, of a sextant is to measure the angle from the horizon to a celestial body?
No, I don't think anybody would disagree with that.
Okay, so then your 6 different correction factors, although a valid issue, really doesn't contribute to this conversation. All right, we're measuring the distance, the angle from the horizon to a celestial body, and whether or not I'm a celestial navigator, well versed in the intricacies of making tenth of a minute calculations on a sextant really doesn't matter. The fact is, it measures the distance in angular degrees from the horizon to a celestial body. Now, the point that I made is that you can measure the same angle from a level down to the horizon if you are at elevation. It's the exact same principle. It's just going the opposite direction. So your objection that the horizon is an intangible object is overruled, because I've just demonstrated that a sextant uses the horizon. You can't deny me the fact that I can measure a horizon down from level. So that's proof number 1.
The horizon is tangible? That's what you're saying?
No, I'm saying that you can use it to measure angles, because you can do it with a sextant. Therefore, you cannot deny me doing it from down.
How does that prove we're on a sphere again?
Okay, it proves that the horizon drops. Now, on a flat Earth, you'd get one thing. On a round Earth, you would get another. It demonstrates that there is a curve there. Now, if you do that in a variety of directions and 1,000 measurements, and you find that there is a correlation to the drops, that's strong evidence of curvature. And if it's in different directions, especially at 90 degrees to each other, there's only one geometric.
Why does the horizon not drop away from me like a ball?
It does drop away from you on a ball.
I actually got a question for you, Bob.
Sure.
Okay, is there anything in the atmosphere that could show the horizon apparently dropping even a slight degree?
Yes.
If you're way down at sea level, probably yes.
Okay, where are most ships when they're sailing? What are they close down to sea level?
They're relatively close to sea level, yeah, within 100 feet, probably.
So if there's any atmospheric conditions that could potentially show the horizon dropping, that would throw it off. Would you agree?
Yes, and that's one of the reasons. That's one of the correction factors, is it not?
I don't know. You're the one going through this. I'm just asking a question. You're the one.
Yeah, there's about 6 different correction factors that you make to get exact readings. But yes, you can get refraction, especially low to the ground, over water.
How is this helping us decide whether we live on a sphere or not?
Okay, well, you're adding additional things. I'm talking about horizon drops from elevation. So it really doesn't have anything to do with it. All right. So that's demonstration of curvature, and if you do it in a variety of directions, there's only one geometric shape that would do that.
Sorry, that would imply that the geometric shape forms the leading edge of the sphere that you're describing, though, doesn't it?
It is the leading edge of the sphere, but
oh, so it's not the arbitrary point that the sky meets the land and will move as you move. It's actually the leading edge of a sphere, a physical location that we could travel to, then.
I never said that.
Well, that's what you've just declared. You've just said it's the leading edge of the sphere, so you've now flip-flopped back to your original position, having had me shut up for enough time for you to insert enough bullshit for people to potentially not notice that you've changed your position back to your own. Yeah, now you're talking over me. This is what happens every time I demolish your argument. I start demolishing it, you carry on talking. So you've just changed your position back from the horizon being an arbitrary point to it being the leading edge of the sphere again.
Nice try, Nathan.
No, nice try, Bob, who's just flip-flopped back to his original position after we've discussed quite specifically for 10 minutes that the horizon is an arbitrary point, an apparent position. Now it's not an apparent position. Now it's the leading edge of a sphere.
My turn yet? May I have a turn now, Nathan?
What? Why is it that when I absolutely rip you a new asshole, you ask me permission to speak?
Well, I don't want to be talked over. So may I speak now?
Nobody's talking over you. You talk over everybody else. You just demonstrated it not 30 seconds ago. I was in the middle of a sentence demolishing your argument where you flip-flopped and changed your position from the horizon being an arbitrary position in the distance that changes as you move to it being the leading edge of a presupposed sphere that you're presupposing. So you are interrupting me continually, and then claiming that other people are interrupting you, while simultaneously flip-flopping between an apparent position for the horizon and the leading edge of a sphere, presupposing you're on a sphere.
Both are
okay. So let me.
Both. The leading edge of a sphere is a apparent position too. Picture a sphere and try to go to the leading edge. Have fun circling around the sphere.
Okay, let me go ahead and answer that since, you know, Nathan brought up this silly objection. What I'm going to do is say this. When I say that it is the leading edge of the sphere, that's a correct statement.
Oh, really? So you're just going to assert your fundy belief? I say it's the leading edge of the sphere, therefore that is a correct statement to make. So you're a fundy.
Are you talking over me again, Nathan?
No, I'm saying you're a fundy.
I don't even know what that is. That must be a British.
Yeah, a fundamentalist who just declares that what they believe is so. That is precisely what you have just done.
Are you going to let me finish, Nathan?
Yeah, you finished when you declared that it is the leading edge of the sphere, and that is basically that. That is what you declared, like a fundamentalist.
I'm not finished, Nathan. So what I said was that the horizon is indeed the leading edge of the sphere, but you objected to that last time. So what I did was I brought it back even further to not presuppose anything, and I said it is simply the border between the land and the sea and the sky. Then you said it was an imaginary thing or some crap like that and can't be used for measurements. And then I pointed out, demolishing your argument, that that's exactly what we use with a sextant, and pointed out the fact that to declare that the horizon is not real for my example, yet the horizon is real and measurable for a sextant. So I just made you appear to be silly. And that's what I'm here to do today.
So does the sextant prove... That's incorrect. What does the sextant prove then? Does it prove that you are actually looking at the leading edge of a sphere? Is that what the sextant proves?
Proves that you're looking at the horizon.
Yeah, I know we're looking at the horizon. We all understand what we're looking at. I'm saying, does the sextant... So I'm still not quite finished, Bob. Can you let me finish my sentence? Yeah, thank you. Please don't talk over me, Bob. It's very rude and ignorant and demonstrates that you are, in fact, losing. So if you don't mind, please don't interrupt me continually. Okay, Bob? Does the sextant prove that the horizon is a physical location or not?
That's a great question, Nathan. Is the horizon a physical location? Well,
no, that's not what I asked. I asked if the sextant proves that the horizon is a physical location. That's what I asked. Don't change the question.
The sextant will prove that the horizon is a measurable position. Yes.
A measurable position. But does it prove that it's the leading edge of the sphere? You seem to be answering a different question for some reason.
No.
It doesn't?
No, it doesn't.
Oh, so what use is this then? That's what Anthony asked earlier. So what does it prove? Nothing.
It doesn't prove that the Earth is a sphere.
Wow. Well, that only took nearly an hour.
No, it proves that
it does not prove that the Earth is a sphere. Thank you, Bob. Somebody cut that out and play it 1,000 times for this retard.
Okay. Now let's go ahead and drop the.
So when we asked you to prove that we're on a sphere, and you told us about measuring the horizon, you've just confessed this does not prove we are on a sphere. Bob the science guy, in quotes.
You don't even know what I was talking about, Nathan.
Yeah, I know what you said. You said this does not prove we are on a sphere. Those were your exact words.
Do you want the second half of it or not?
What, the bit that does prove we're on a sphere? Oh, well, that's kind of what we've been asking for an hour, but with you going around in circles and talking over everyone on the panel, kind of like you're doing now. So that's what we've been doing, asking you the original question, proof of Earth curve. We've gone round and round and round in an hour, and we still haven't got there. So is the second half going to prove what the first half that we've talked about indefinitely, this pointing at the horizon and measuring it, that you've just declared unequivocally does not prove a sphere? We're going to go beyond that and actually prove it with something different. Again, you're talking over me. I haven't quite finished. You don't wait for gaps because you're a wanker. We all know that. But yeah, so yeah, rather than telling us about, try and let me finish, Bob. I know it's difficult. You have cognition problems. I know. You maybe were socially taught how to have a conversation by your mother. Now that's not my problem, but you still will listen to what I have to say, Bob. So rather than going through the bit that does not, you're doing it again. I'll have a word with your mother later, son. Okay. So rather than proving the bit that doesn't prove we're on a sphere, Bob, yes, try and use the bit that does prove we're on a sphere. That would be great.
Good. All right. Now that you're done, I'll finish. Now, the horizon itself on a sextant simply proves that it's a measuring point. Now, combining sextant readings from different locations does prove the sphere.
How so?
Really?
Yeah, it sure does.
How?
No, it doesn't.
Because the readings that you get from a sextant only work on a sphere.
So it's back to another formal logical fallacy, affirming the consequent. So if the Earth is a sphere, we will get different measurements from a sextant at different geographical locations. We do get different locational measurements from a sextant, therefore the Earth is a sphere. Again, Bob the fallacy guy with an affirming the consequent formal logical fallacy. Now, do you have anything other than fallacy, Bob? Because I waited for the second half, and it just seems like now you're talking over me again. So I listened to your full logical fallacy. You spelled it out for us, and now you're talking over me. It seems when I get to the demolition of your logical fallacy, you talk over me, don't you, Bob, like you're doing right now? So yes, Bob, I listened to both halves. I listened to both halves of your logical fallacy, Bob. You're not going to talk all over me. This is your last chance to shut your mouth. Then I just kick you out because you have been obliterated here. We listened to both halves of your You're still talking, Bob. You're now interrupting me again, just to point that out for the audience. So we listened to both halves of your formal logical fallacy, Bob. And neither half of the logical fallacy proved we're on a ball. Both halves demonstrated that you know how to assume your outcome and beg the question. So, Bob, no, this didn't prove we're on a sphere. In the slightest, my friend. It was by definition a failure by a pseudoscientist to prove we're on a sphere. He also declared halfway through the example that this doesn't prove we're on a sphere. So I'd call this pretty much a win for us and a loss for you.
You're going to call it a win anyhow, one way or the other. It doesn't matter.
Yeah, I'm going to declare your claims invalid, Bob. That's what I'm going to do. I'm going to declare them invalid based on the fact that you used logical fallacy. That is what I have declared. Okay?
You can do whatever you want, Nathan. I really don't care.
Yes, I am doing what I want. I'm declaring that you are wrong. And the reason is as follows. You have formulated a logical fallacy.
Go ahead, carry on.
Truth is hilarious, isn't it?
Pretty sad. Bob the science guy showed up with no science for his ball.
Sad. It's pretty sad that
no proof. No proof for your ball, no science for your sphere, nothing. He said nothing.
Pound says he now circle jerks back to the horizon and tries to make the exact same example again. I'm willing to bet a pound that's precisely what will happen. Circle jerker.
All right. Well, next thing you do is you measure the distance between degrees of latitude, and that, because there are 360 degrees in a circle, you can actually measure the circumference of the Earth from that as well and calculate the R.
So you're presupposing that that circle that you've travelled in actually relates to the outside edge of a sphere. So you're not actually doing what you say, which is measuring based on a circle. You're presupposing it's the outside edge of a sphere, giving you a spherical R value that you will derive. So you move in a circle and then declare that it's the outside edge of a sphere, giving you a spherical R.
I have too many pieces of evidence that point to the same R.
Hallelujah. Hallelujah, hallelujah. Go in peace, in R you trust, you bloody religious fundy. If you think you've got proof of R, I'd expect you to give you the best immediately. You've given us nothing but logical fallacy. So if you think you've got lots of proof, sod off and believe it.
All right, next thing you look at is great circle courses. They have a curvature to them that determines an R value.
Yeah, you've just declared that you've gone in a circle and declared they've got curvature. So like I just pointed out, you've presupposed you're travelling on the outside edge of a sphere. I've now said it twice. Not only have you not acknowledged what I've said, you've restated it like that somehow affirms your position when begging the question.
It's demonstrable.
Oh, is it really? No, it's fundamentalism. It's not demonstrable. It's based on logical fallacy. It's not empirical. It's not based on science. It's fundamentalism. Your religion. You declare it and we must accept it. That's religion. That's fundamentalism, not empirical.
Do you want to talk about great circle courses or not, Nathan?
What, when you assume that you're travelling on the outside edge of a sphere, when you tell us that it's a circle route? So you move in a circle, but then you tell us that actually you're moving over the outside edge of a sphere on curvature. Well, that's your presupposition again, my friend. Another begging the question fallacy from Bob, the fallacy guy.
I love your fallacies, man.
No, your fallacies, you dick. I'm pointing out your fallacies. So you love your fallacies. That's what I'm pointing out. You love them because that's all you've got.
Now, do you want to go over great circle courses? We'll go ahead.
What? And assume we're on the outside edge of a sphere? This is the third time. Man, it seems when I get the habit, the routine of these circle jerking assholes, I can then get them to circle jerk like that. He's gone through the same circle 3 times in about the space of a minute. Now he's back to his original routine of talking over me.
Nathan,
maybe you should just call it sphere
angry man. That's in the chat right now. Yeah, I would tend to agree with that.
Oh, now it's talk to the chat. Oh, right. Time for a red herring. Or maybe an appeal to consensus. Right, Bob? Let's take an opinion from the consensus in chat, rather than address the logical fallacies I've used continually. Or maybe I'll talk over Nathan again. That's always a good one.
Well, yeah, let me get a word in edgewise. So if I'm going to get anything in, I've got to talk over you, Nathan.
Look, you got in plenty. I heard you formulate every logical fallacy. Yeah, if the Earth is a sphere, then we'll see weight changes from the equator. We see weight changes from the equator. Therefore, the Earth's a sphere. If the Earth is a sphere, then we will measure differences with a sextant. We measure differences with a sextant. Therefore, the Earth is a sphere. I've heard your logical fallacies, dickhead. They're not very good.
You can use a sextant on a flat Earth. It just
pound. Who owes me a pound? Someone owes me a pound.
All right, but in any event, we're going back.
In any event, I have absolutely confirmed Nathan and his definite correctness in his prediction that I would be a circle-jerking asshole and come back to the horizon within 60 seconds of me betting everyone on the panel a pound. That's precisely what I'll do. Yeah, you're predictable, Bob. Very predictable.
I really don't care what
it actually does work on a flat Earth. The only thing you need is a map projection. Any map projection, any type of map, and it'll work.
What's a map
because all you need is the angular relations in relation to position on the Earth in some kind of projection, and then you can use the longitude and latitude to coordinate with the sextant. The shape of the Earth is completely irrelevant in this process.
Well, you're wrong on that. But in any event,
no, I'm not wrong about that.
Let's take a flight from
It's all about the angular relations to the position of the Earth. That's what the sextant works with.
Okay, can you use a sextant on a Mercator projection?
Sure, you can use it on anything, any kind of map. You can explore any kind of map using a sextant to measure out positions of the heavenly bodies in relation to your position on the Earth. And it works. Doesn't matter what the shape of the Earth is.
You have to get the latitude and longitude, though.
Yeah, and any map will give that to you, no matter the type of projection, no matter what you assume the shape of the Earth to be. All you need is the longitude and latitude.
You have to have the latitude and longitude from your position.
You know why? You know why? Because the longitude and latitude are based on the angular relations of the celestial bodies with the position of the Earth. And that is exactly what you use to coordinate yourself with a sextant on the Earth, no matter the shape.
But a sextant only measures correct angles on a sphere.
No, it measures the correct angles on the Earth, not on a sphere.
Just done it again. Just declared his fundy belief again. So he's just said it only works on a sphere. So in other words, Bob's made up his mind. He's a religious fundamentalist. He's decided what shape it is, and that's what it is. Fundy.
Can I add something, Bob, that maybe you can use to validate what they're not allowing you to use, and then I'll let you continue. But what you're saying about the sextant, I agree with you, is correct. But I also would say that there is a way for you to conclude with just using Polaris and a sextant that you are on a sphere. Because I did something similar, but with the sun over the equinox.
And you don't know the difference between cosine and sine, mate, so it doesn't matter.
Right? I'm just explain this real quick, and I'll let Bob run with it. But right, so the way you can conclude that this is a sphere is by you'd start at the North Pole, for instance, right? And you'd measure the Polaris. It should be exactly 90 degrees above you, because that's where it's supposed to be. And you would move away from the equator southward.
Sorry, Kosho. Sorry to interrupt, Kosho. What's the equator exactly?
The equator, you can define it in several different ways. I haven't brought that up, though.
You just said the word equator, so I want to know in this
example.
I
said the North Pole.
I hadn't finished asking my question. In this example, what is the equator?
The equator would be the distance that's it was like 6,000 miles from the North Pole, but we haven't gotten to the equator. I'm just at the North Pole only.
Yeah, you said you're going to travel to the equator. I want to know where you're traveling to.
We're just traveling southward. Yeah. So we'll just point the compass northward and travel the opposite direction.
Northward. So that would be outwards then.
Yeah, southward.
Outwards. So that's outwards. Out. Not up,
whatever
not
word
down.
You like to use,
outwards.
It's the same way. You would just use the.
Shout out to Retro Bill for the super chat. Says Bob the most. I can't read it with the sun on it. I'll wait till it goes up the page a little bit. Lamentable. There we go. Debate performance in history of the show. Yeah, I'd agree with that.
Kosho, I've got a question for you.
Hold on, if you just allow me to continue real quick, because I feel like no point gets completed here, and then whatever you can ask the question. But yeah, so southward, outward, whatever word you like to use, just go opposite of the North Pole or north.
No, the opposite of the North Pole. Opposite meaning that it's antipode.
Meaning that you would point it north and walk the opposite direction.
Opposite in what way? Opposite's quite vague. I'm trying to establish, when I travel in that direction, am I travelling towards a different pole, antipode to where I was? That's why I asked what the horizon was. I want to know what you think I'm doing when I make that journey.
Sure, I would say so, but I know that you guys disagree, so I don't want to...
Well, let's just hear it. Don't just assume it and assume the audience knows. I've asked a very direct question. I want an answer. So tell me, what is it that we're doing when we travel? Are we, as I correctly assume, travelling antipode and presupposing we're on a sphere?
Not at all. Not at all.
We're not.
All we're doing is
so we're not traveling down. Okay, I'll just get that clear. We're not traveling. Bob seems to have piped up. Yeah, I know I've got him on the ropes, Bob. I know you need to come to the rescue. Yeah, I know. This is me about to batter him. So, Bob, you can just sit back and enjoy the show, my friend, while I drag out Kosho's presupposition. I know he doesn't want to confess it, but I know it's there, and so does everyone on the panel. It's just fun to watch how he obfuscates it. But don't defend him, Bob.
He said he was traveling south, Nathan.
Yeah, south? Is that antipode, Bob? Bob, yeah, maybe you can answer then, Bob. Bob, is south antipode to north in this example or not?
And actually, it's not even involved. It's not at all involved. The flat plane or sphere wasn't even involved.
Well, that would be absolutely involved then, because those two things are quite specifically contrasting each other. So, while you declare it's not involved, it's the crux of your point!
No, it's not. We're walking away from the North Pole. That's all we're doing. We're just walking away from the position that we started making our measurement. That's literally the only thing we're doing, okay? So you don't have to worry about where the antipode is. You don't have to worry about if it's flat or round. You're just walking away from that point. So if I just continue,
if it was a ball, you pretty much would have to worry about that, though.
Just let it get to the end, then.
Honestly, all you'd have to do is see where you started, and if that was pointed north, when you walked a little bit south, just make sure that every time you walk, keep the compass in the same direction. So make sure you're continuing the same direction away from it.
Oh, but the compass points to magnetic locations. It's not that reliable compared to celestial orientation.
Well, right. That's why we're taking this measurement. So that's what you do is you walk 111 kilometers southward from that position, and you take another measurement using the sextant. And you continue to do that every 111 kilometers. You can go all the way until you get to where it's 0. But the one thing that would make a distinction between a flat plane and a sphere is on a sphere, those...
Sorry, you're now assuming your outcome. Stop.
I'm sorry.
You're now assuming your outcome. You're now declaring that we're on a sphere for this example, aren't you?
No, I'm comparing two models.
No. Just giving it as a false equivalency doesn't work either. Just because you demand that we have a straw man example to put alongside your begging the question fallacy doesn't change the fact that you've just decided to place this example on a sphere.
Hey, Nate, why don't you be quiet?
Bob, I'm going to kick you out. So you think you need to defend him, do you, Bob?
Nathan, you're assuming what I'm saying incorrectly. If you let me correct what I'm saying.
No, you said, if we're on a sphere. I heard what you said, and then I pointed out that that's begging the question. You then said, no, I'm comparing two models. Then I pointed out that that's a false equivalency. So I do know what you're doing. I'm just pointing it out. And where it's fallacious.
Find out and see which one of us looks like an ass afterward. Okay? The reason I'm using that is so that we have something to compare our measurements to. We know what would happen on a sphere, and
there he goes again. So we automatically know it's a sphere then, in this example.
No, you'd have to make these measurements first and conclude that. Unfortunately, we already have, and many people have, and from Polaris, each 111 kilometers southward, it only goes linearly in 1 degree each 111 kilometers, which would not happen on anything except for a sphere.
Oh, so you are presupposing a sphere like Bob. You're just putting the presupposition at the end of the statement rather than the beginning, which is exactly what Bob did. So Bob also, getting rumpused again, it seems. Getting rumpused. So, yeah. So you've just put the presupposition at the end, Kosho.
Yeah, so can you really call that a presupposition then?
Yeah, you can. It just gets declared at the end of the statement. It still presupposes that the Earth is a sphere when you make this observation. You just declare that fact at the end of the statement rather than the beginning. It's still absolutely, unequivocally, in case Bob can't help himself. Bob can't help himself. He knows his teammates getting battered. Right, Bob? No. So you've got to join in, haven't you, Bob? Yeah, it doesn't matter whether you presuppose it at the beginning of your assertion or the end. It's still a presupposition, Kosho. You don't have to like it. And you can all rumpus the living hell out of me while I point it out. I don't mind, dickheads. In R you trust.
Okay, well,
You must
fine,
presuppose the ball. It must happen at some stage. With you, it just happened at the end. And now I'm being rumpus, aren't I? While I demolish your religious belief, your presuppositions. Yeah, Coco. Yeah, you keep rumpusing me while I crap on your religion. Based on your use of a presupposition, you could just rumpus me. It's all you can do. Try and stop the audience from hearing your demolition.
No, well, I'm trying to get you to stop so I can actually correct you in what you're saying, okay?
No, you don't need to. You've explained it. If we're on a sphere, you just said it at the end of the statement. It doesn't change the fact that you presupposed you're on a sphere.
Nathan, the reason it's not a presupposition is because you're making the measurements first. If the measurements would have gotten, you would have gotten further and further angles, the further south you went in a linear fashion, then you would have not been able to conclude it was a sphere. But that's...
Sorry, you've concluded it's a sphere based on star movements that you observe. So you see something change in the sky. That's it.
No,
that's what you actually observe. Something changing as you move in the sky.
Yeah, the angle of the object in the sky.
Yeah, we heard. I know. But then you have to actually make your conclusion. So you observe things in the sky changing as you move. Yeah? That doesn't prove jack. But then you presuppose it's happening because you're on a sphere, don't you? And say it must work.
The only proof we really have is that there are angular relations with the heavenly bodies and the earth. And what you're going to conclude the shape to be deduced on that knowledge you gather, that's up to you. And there's where the presupposition comes in. But you can't smuggle in R without us taking notice.
I didn't smuggle in R at all.
Yeah, you
but,
did.
If any
you did.
Yeah, when you said if you're on a sphere, or things like that can only work on a sphere, that would be you smuggling in R.
No,
I'd like to ask
in the outside.
Does the section give you an accurate position on Earth, Nathan?
I'd like to ask you questions for the Globers. Now, imagine you're going to invent the compass. We all know how a compass works. It always points to the magnetic North Pole and never points to the magnetic South Pole. Now, you're going to have a compass and it's pointing in a direction. You don't know what the directions are. How are you going to find that? You're going to have to find a fixed point. What fixed point in the celestial stars do you point that to? You're going to find that it points it to Polaris, correct?
You understand the compass doesn't point to stars, right?
It points to the magnetic North Pole. Is that correct or not?
Yes, that is correct. So why are you bringing in stars?
Because I'm trying to find out where your logic is heading. Because if you have any, you'd figure this out. Now, if you're directly underneath the sun at noon, directly overhead where there's no shadows, and you've got the compass in your hand, you wait till nighttime, and you see that, okay, that's pointing to Polaris. Now you can figure out that on the east side, that's where the sun rises. On the west, it sets. Now, is there a point on a compass that points south? Now, is there a fixed position that you can find that goes south? We know that there's a fixed position north, fixed position east and west because of the sun. Now, is there a fixed position going south?
Well, you would just fix it north and go the opposite direction.
Yeah, but is there anything that's celestial, whether it's a star or the moon or the sun, that is fixed towards south?
Now, north of the equator,
That's Colin Turner for the super chat. Thank you very much.
Pole star, and south of the equator, you can look for the Southern Cross.
But the Southern Cross isn't fixed; it also rotates. It moves.
Yeah,
not like Polaris.
Point of it, pole. And that that's where the celestial sphere rotates around at these locations.
But it's not a fixed point in the sky like Polaris is. It's not fixed as if you're on the equator where the sun rises on the east and sets on the west. So I just want to know if there's a fixed point in the south.
Polaris isn't exactly that center either.
It's the most fixed position of any star that we have in our universe from the Earth's point of view.
But it's not perfectly that
similar to it, not even on the south.
Jesus.
So I just want to know.
Sorry, guys, hold on a second. Guy, I don't know what's your name, Eben.
Zinder, what are you doing?
When you're talking, I don't know if you're moving your microphone around or what.
So Nathan, can you see Polaris, the North Star, from below the equator?
What's the equator?
Can you see the pole star, the Polaris, from south of the equator?
What is the equator, Bob?
90 degrees south, or 0 degrees latitude. It's a line on a map. You tell me whether or not you can see Polaris south of that, away from the North Pole.
Yeah, I'm trying to figure out what the equator actually is, though, in your mind, Bob. Where am I traveling to? Is it the outside edge of the sphere again?
I simply gave you a point. 0 degrees latitude. Listen,
yeah, the reason I asked, though, Bob.
Can you see the Polaris from south of that, say 20 degrees?
Before you ask a question to someone else, can you answer my question first, please?
About the southern celestial pole?
No, the south point of a compass. Where can you fix that if you didn't have a fixed point, which is northeast, which is the sun rising, and sun and west, which is the sun setting? Is there a fixed point that you could go south first and then affix all the other points in a compass?
There's a celestial pole in the south, but it's actually a void. Basically, what you'd have to do is look at star trails and see what's in the bullseye of that. There's not a star there like there is in the North Star.
That's DMT Matrix for the super chat. Bob competed first place. Dumbest person I've heard. Thanks for the chat. Wow.
Well, thank you very much. I'm number one. So, Nathan, now I ask you a question. From 20 degrees south latitude, can you see Polaris?
I don't know. I've never checked.
Okay, so you don't know.
No.
Can you see the Southern Cross from England?
No, I don't believe so.
Okay, tell me why.
I don't know the answer to that, Bob. What's your claim?
Okay, it's because the Earth's spherical.
So, let me get it straight. If the Earth is a sphere, we will not see the Southern Cross from England. We don't see the Southern Cross from England, therefore the Earth's a sphere.
I have an alternative explanation for it. When you're in England, the Southern Cross is beyond sight. It's out of view. You'd have to go further south in order to get it back into visibility again.
So it's further than you
I'll just say again, Bob, can you just acknowledge what I've just said? So, if the Earth is a sphere, I will not see the Southern Cross from England. I do not see the Southern Cross from England, therefore the Earth is a sphere. Is that correct?
No, it's not. It's evidence that the Earth is a sphere.
No, it's not evidence. It's called an affirming the consequent, formal, logical fallacy.
Point it out for me then, Nathan.
I'll say it again. No problem. If the Earth is a sphere, we will not observe the Southern Cross from England. Precisely your question. So you asked if I could see the Southern Cross from England. I said no. And then you asserted that it was because the Earth is a sphere. So now I'm formulating that. It's called a logical syllogism. The only problem being that it's actually a formal logical fallacy known as affirming the consequent. If I cannot see the Southern Cross from England, then the Earth is a sphere. The Earth is a sphere because I cannot see the Southern Cross from England. Correct, Bob?
Nope.
No, that's what you said. You asked me if I could see the Southern Cross from England. I said no. Then you explained that the reason for that was because the Earth was a sphere, Bob. So absolutely yes. It's just yet another logical fallacy, Bob.
Nathan, it's evidence for a spherical Earth.
No, it's called an affirming the consequent, formal, logical fallacy. Not evidence for a sphere, evidence that you know how to formulate a fallacy.
Okay. How far?
Yeah, it's not okay. Another time that when I rip your argument to pieces, you go either or okay, or yeah, right, or no, Bob. That's your argument being handed back to you on a plate.
Laughing at you wouldn't be polite. So what I do is generally just say okay.
Okay, what? I'm correct. It is a formal logical fallacy known as affirming the consequent, as pointed out and detailed now on 3 separate occasions for this example you just gave us. Yeah, it is. That's okay. Yeah. Correct, right.
That's fine. Go ahead, call it whatever you want.
And affirming the consequent, formal logical fallacy. If P, then Q, Q, therefore P. The fallacy being that one doesn't necessarily follow the other. For example, if I eat 10 hamburgers, I am full. If P, then Q. If P, I eat 10 hamburgers, then Q, I am full. I am full, Q, therefore I ate 10 hamburgers. P. If P, then Q, Q, therefore P. The problem being that one doesn't follow the other. So asserting that just because I'm full meat I've eaten 10 hamburgers is a fallacy, because I've actually eaten Chinese food. You asserting that because I can't see the Southern Cross, the Earth is a sphere, is a fallacy. Okay, Bob?
Spent a lot of time on...
Okay.
Whatever you say, Nathan.
Yeah, right. Okay.
Whatever you say.
You know, if you included
you just amused
rotation...
me, Nathan. I stated that it was evidence of a globe. I'm saying that you can't see it because the Earth is a globe. But I'm saying, in this case, that is evidence of a globe.
No. Again, for the 4th time. For Bob, a circle-jerking retard. It's not evidence for a globe. It is evidence that you can formulate a logical fallacy. If the Earth is a sphere, insert bullshit here. Bullshit has been inserted here, therefore the Earth is a sphere.
Hey, Nathan, I'm going to have to bring up the rules of the chat for you. No foul language, or you may have to be invited
I'll
back.
just reiterate the rules to you then, Bob, because clearly you don't understand my rules. And they are, I assure you, my rules. You will do as I say and not as I do.
You know, Nathan, with this evidence, because I mean, for me, I understand what he's saying. He's not.
No, I'll say it again for Kosho. It is not evidence. It is a formal, logical fallacy known as affirming the consequent. Was that slow enough?
Nathan, you don't know the difference.
Not evidence of a sphere, but evidence that you can formulate logical fallacy.
Okay, I'm not going to disagree with you, Nathan, because
I'm right. It is, in fact, a logical fallacy. I formulated it for Bob 3 times based on exactly what he said.
I just do the song, and you did a couple other things with it, and I think that's wonderful. A bit of a waste of time, but that's all right. So I'm going to be quick.
No, it's not all right. It's not all right, Kosho. It's a logical fallacy. You declaring afterwards that it's evidence to back your teammate also won't change the fact that it's a logical fallacy. Not okay. Logical fallacy.
Spend a lot of time doing that. I'm not even speaking on that. I'm just giving also to Bob.
Yeah, you were speaking on it. You said it is evidence. So now you're a liar, just like yesterday, when you claimed that the body was like the Earth and the cells were like Earth, only to then later blame it on Zinda because you're a liar. Yeah, you're a liar, Kosho. So yes, you did absolutely declare, as Bob declared. It is on point. Yes, it is talking to this subject. You declared, again, like Bob declared, that it was evidence of a sphere Earth. And I'll say it for the 6th time. No, Kosho, it's not evidence of a sphere. It's a formal, logical fallacy known as affirming the consequent.
Nathan,
not evidence. Not evidence.
Is this your strategy?
To point out the flaws in your reasoning? Yeah, that's my strategy. It's also the way I win, because I point out where someone has a logical fallacy and then explain the logical fallacy, then formulate the logical fallacy and explain it in detail 6 times. So yeah, that's me winning.
We're not interested in any logical fallacies, Nathan. We're trying to sit down and present the evidence you're asking for.
We're not trying to formulate logical fallacies here. We're trying to present evidence. Yeah, but you're not, Bob. You're actually presenting fallacy.
How about this? I'll present some evidence.
2.5 hours, man. You haven't presented a damn thing.
This is going in circles, and that's like, we don't have to do that. So I'll add.
Absolutely beautifully said. Yes, we are indeed going round and round in circles, as you assert that your logical fallacies are actually evidence of Earth's sphericity. They're not. They're logical fallacies. If you're watching this in the Nathan Oakley 1980 audience, then stay tuned, as we will have an after show to follow this. A massive, huge, enormous thank you to all of the people who've tuned in to the Nathan Oakley live stream, and hopefully sharing and subscribing. Also, a massive thank you to all of the debating panel for making this live debate possible. Be sure to check out nathanoakley.com and visit the forum. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!